Okay. Alright, we're probably not gonna go to the other ones. Okay, so we have two circles intersecting. Sure. And we could put your favorite countries MO besides USA and Taiwan, which would be our favorite. Ah, that's tough. There's so many good ones. Oh. I'm gonna say Russia, but with very low confidence. I think there's a lot of countries have a lot of really good ones. I'll put it that way. So B reflect line A, 01, 02. I also think there's like a quantity type thing. Like some countries will have more original problems per year than others. Thank you, Fury Guns, for the follow. Like for example, Russia definitely has like a lot of volume. Like their national Olympiad, the All Russian, has like different grade levels. Yeah. Like Taiwan has some good problems, but the good problems tend to show up on the TST, and there's not that many. They don't have that many original problems. It's just the ones they do have are on average like quite nice. Okay, so oh jeez, I painted myself into a corner. I wasn't expecting to have to draw T. Okay. Oh jeez, how do you draw a common tangent? Oh no. No, how do I draw the common tension? Is there a tool? Why can't I construct a circle tangent to a circle and a line in GeoGebra? I don't know. Okay, we're gonna do tangent on both circles. Does that work? Tangents. Oh, it works! Haha! Alright, we're saved! Okay, I'll win. Yeah, I didn't know that was a command either. Because the picture for the command was like, it shows a point. All right, P and Q. AX over PX equals. What? What kind of condition? Wait. The heck is that? Oh, wait, that just means they're parallel. Okay, fine. I was like... Okay, so there's a parallel thingy. Moreover, PA and QA get extended such that... Wait, what? What kind of condition is this? Is that a harmonic bundle condition? It's like AR... No, it's about... It's C times PQ. Oh, it's on the matriarchs. Frick. Learn to read. Okay, that's a lot worse. Just waiting. AX over PX. Okay, how do I construct Y? Jeez. It's law of science. Okay. Yeah, it's like by the rotation by the same. No. Are arcs AP and AQ equal? Let me first see if I'm silly. Yeah, they're not equal, so this is gonna be a pain in the butt. Oh, it's major. How do I draw this diagram? Someone please. Okay. Are the triangles gonna be similar or something? No way, right? So something is similar to something else. I don't know. We're just gonna wing it. I give up. I officially give up. We're gonna call this C1 equals distance A x over distance px and C2. Let me make sure I define these correctly. AY over QY, AX over PX. Good. And now we just fudge them so they I want to show more digits, so let's do the so we're supposed to make these equal. That sucks. 107. Good enough. Okay, and then we extend PA and Q. What the heck? Such that, okay. So, R equals A plus A minus P times. Okay, maybe I should not make. What the heck is this condition? Okay, what the heck? Excuse me. Excuse me. I think it's C times PQ. No, oh, frick. Oh, jeez. Aww. Excuse me. Does Y lie on AQ or arc AQ? It should be arc, I think. The heck is this condition? I should have done the Mexico problem. We did Connoisseur and 2004. Okay, so I'm gonna do what's called, we're gonna bite the bullet and actually construct the Apollonian. So... Oh, jeez, how do you construct the Apollonian? I take the foot of the angle bisector, right? Okay, x1 equals... bisector. Okay, so y is supposed to be the point that intersect. So I would like to construct the harmonic conjugate of y1, and I can do so by y1 intersect polar of y1 with respect to the circle centered at the midpoint of AQ with passing through Q. Take that polar and intersect it with line AQ. I'm gonna call it Z because we're never going to look at that point again. And Z is probably really far away. Let me check that I responded correctly. Yeah, that should be fine. Okay, and then Y is intersect omega 2 with the circle through y1 and I pick the other intersection. What? Hey, no, don't do that. What? Huh? No, I want Y to be the other one. Why won't you let me take the other intersection? want to rename Z to Z1 to remind ourselves that it's useless. And rename C to Y. And YQ equals segment YQ. YA equals segment YA. And now, where is R? This was R. We're going to rename C1 to C because now it's actually the correct constant. And now we'll do this. Okay, so QS equals segment QS blue. We're going to hide the Apollonian that we constructed. I'm going to hide X1 and Y1 because they are literally... Actually, maybe I won't hide them. They might come in handy. I'm not sure. We'll see. But now O is the center of ARS. And XY is line XY. And I want O to be on that line. God freaking. Why doesn't the intersection change when I... The heck? No, I'm almost there. I refuse. We're not giving up now. Okay, C and then... Alright, now I have two distinct Y points, Y1 and Y2. And one of them should always be correct. So at this point, when it flips, I'll say instead Y equals Y1. Haha! Ha 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 ha. The frick? Why can't I get it to... Oh, it's O. I was looking at the point S. I'm okay. I was like, why won't it pass through that point? Okay, we did it. We have succeeded. Alright, so what am I supposed to do with this now? So the angle bisectors, yeah, like I feel like I understand none of the conditions in this problem. Other than there's a bunch of, let's see, PQ, AR against PQ. Like, what is AR against PQ supposed to be? If it was like PR, I would be less more happy. Can you scroll left? Is it like, are those things gonna concur? They might. I mean, you can't really tell. Oh, let's move some stuff around. Yeah, it looks like XY is gonna pass through the. That's a little too. That's a little too coincidental. Let me try it one more time. Yeah, that's too coincidental. I bet they concur. Then there's nice methody things. Yeah, I guess X and Y should be images under. That seems too good to be true, actually, now that I'm looking at this. Like P maps to Q and X maps to Y? What if we randomly draw in a third circle? I feel like XA and YA might be tangents too. Like, I think maybe you have like AY might be tangent to omega 1, and then AX might be tangent to omega 2, and that explains the times C condition, because then it says the spiral, there's spiral similarity sending like XPQ to XAR or something. Or something like this. PX, yeah. I feel like I tried a few cases and it was so coincidental, I'm convinced that they concur here. Red lights are... The problem is that they're only parallel when, like, O lies on XY. So, like, the diagram will always be off by a little because I'm eyeballing the O lies on XY line. Right, like if in general it's not true. I need the special case where XY passes through O. But I don't understand what the point X is doing. Like, what the heck? What is ARS? Like, what is that? Who are you? Yeah, one variable inequalities is probably calculus. I have a thought. What if the C's aren't related? That would be the most masterful bait of all time, but I can see that happening. What if this C... YA... I want to check this. I'm curious whether it's the same constant. Because if so, I can drop that condition. Wait, why are C1 and C2 different? AX over PX. Oh shoot, I misdefined it. Yeah, cool. They should match. Okay. Sad. Okay, that was worth a shot. Okay, anyways, what does the problem want me to prove? I actually haven't looked at that yet. XPA is equal to YQA. So like, this arc is equal to that arc. Is that true just if they're parallel? Yeah, if they're parallel, then the arcs are automatically equal? Maybe? Is that true? That seems like it's a long shot. Equal if and only if parallel, if and only if concurrent. I agree, concurrent if and only if parallel. Why does parallel imply XPA equals YQA? Is that obvious? Am I being dense? If you look at the image, don't you need AT perpendicular to X01? Okay, so I'm going to, you're asking me to construct the, we're going to call it A prime. It's the intersection of the line through Q parallel to line PA against so that okay, why is that always, that doesn't depend on, okay, why is this triangle isosceles? Because this angle, okay, I should just follow from the tangent? AX over PX condition. Oh, what? Oh, so AX over PX and oh, that's so smart. Okay, so genius. Okay, so this homotopy thing tells me when I do this. So if X and Y were images, I would then say this is equal to this, but then this is equal to that. Same ratio. Yeah, XP maps to QY, and then YA prime is like Yeah, it's like a copy of this. Oh, so even if I don't assume anything, if PXA maps, no. Okay, breathe in, breathe out. Okay. XPA maps to QA prime Y is the hope. If X maps to Y, then it does. And then PX is QA prime Y, and then YA is equal to YA prime, and so you'll get two angles are congruent. So AQY equals A prime QY equals APX. Okay, got it. I understand. So what we have is the so if we claim that X maps to Y via homothety, if so, then done by noticing directed angle A prime YQ is equal to AXP, but also equal to whatever it is, PX C inverse times. So direct angle cool. All right, that's fine. No, so now I just want to figure out what this point O is doing and what the points R and S are doing. So there's a spiral sim, right? XP, like XAR is equal to yeah, we have an unconditional spiral sim actually. I don't know how I didn't see that earlier. Like we always have direct angle XAR is equal to XAP is equal to angle XPQ. And since AR over XR equals yeah, so there's a spiral similarity at X which takes XPQ to XAR. So phrased a different way, spiral similarities come in pairs. So that means there's one taking XQR to XAP. Ratios mean spiral sim normally, right? I wouldn't say usually, but it is certainly a very good way of handling them. Like it's pretty common. No, did I screw up? It's AX. Yeah, AX is fine. Yeah, XPX. Okay. Okay. Midpoints, I think, is probably what people were talking about. So I've used up, I think the C condition is sort of mostly used at this point. Like it gave me 2 spiral sims and then also tells me I want to show X maps to Y. What does that have to do with ARS? Well, I have control over XAR. I can switch it from control over XPR. So doesn't tell me anything about this. XPQ and XAR. What do I do with this? Yeah, I don't get it. What is AX? What are... I know there's this spiral here, and I don't know how I can use that to get something. XAR. Like I have control over either triangle XAR or triangle XQR. Maybe AR is better. I can say like you like the perpendicular bisector of AR or something. It's rotated from perpendicular bisector of PQ. Y is on or not the light green circle? It's not on the light green circle for sure. Because if it was, then X should be by symmetry, which is not the case. Man, what am I supposed to do here? XAR. So what do we want to show? Our goal is to show that X is the image of Y under homothenity at T. That's where we are. And I have a spiral sim that I don't know what to do with. How old are you? I'm 24. What is the locus of O as you move X and Y? Oh, maybe it is a line. Yeah, the locus of O should be a line because it's formed by the intersecting these two perpendicular bisectors at fixed, and these ratios move linearly. So it's something like, okay, like XA, this ratio is equal to whatever it is here, like XP over PM. And this is equal to like, XP over XA. Let me name these. Is the locus OM? Yeah, it's OM for sure. And the reason is that you can. I can calculate what this thing like. This A and length A and R is AR over 2 is, so it's like C halves times C times PM. So it's a spiral sim that takes XPM to XANR. And so that, and this is. Oh, hang on a minute. Wait. Circle A and R. Oh, they are equal. Yeah, okay, so like A and R is equal to A and S. So AO is actually an angle bisector? And it's like. Okay, oh, bisector. That seems like I should care about it. Yeah, it's because AR is equal to A. Oh yeah, that's. Yeah, it's an angle bisector. I'm taking the isosceles triangle. God damn it. Yeah, so it's just the angle bisector. I'm. It's one of those days. That's silly. I shouldn't miss that. So it's angle bisector. I'm curious, what is this? What's the angle bisector of angle PAQ look like? It passes through. Pass through anything interesting? If PX and QY are parallel, we don't know that. That's what we're trying to show. Maybe this parallel to all of them. Yeah, it's possible this line AO is actually also just parallel to XP. Let's check that. Bernoulli is only enough for Z less than 0.9962. I mean, that's fine. Just do something else for the other case. Yeah, if AO is parallel to PX or QY, then that is what we want. Okay. So AO looks like it's... Okay, fine. So it's like I want SAX equal to RAY or something? Or angle SAY really, or something. Is PA equal to XO? No way. If PA equals XO, then QA equals YO. Actually, that might be possible. I don't believe it though. Yeah, that should be filter symmetry reasons. Freaking. Bash. What would I do though? Like, I don't have a setup either. If we reflect Q over Y and AO, what happens? So that's Q over AO. And Y over AO is somewhere down there. I don't know if you expect something out of that. What are you? What are you reflecting? Q over AO? What? I don't know why it's not up there. Like, this is line AO. It looks there. You want YBQ prime collinear? Doesn't look like it. Oh, Y was somewhere way south. But I mean, I didn't see anything coming out of it. Maybe I should actually use my spiral simulator. So if I was to simulate X. Oh, that looks like it's going to be very useful. Okay, is that really true? So XPQ, then YPQS, right? Also. Yep, alright, yeah, alright. Alright, let's click. I'm gonna hide this stuff that I don't think matters anymore. What is this one? Don't think I need that. I don't think I need that either. These points are distracting. Wide frame is a distraction. Okay, so is this true unconditionally? If I like... Yeah, it's true unconditionally. Why is that cyclic? I don't know. I just noticed it just now. I really... should have called him earlier. Not only is it cyclic, I think when it's cyclic it passes through like a useful point here. Oh, these circles are very strong. Like these second intersection points are also showing up now. So why is this the case? Actually, first of all, does that unconditionally pass through? All right, we're gonna. Let me just do it. All right, we're onto something. This is going somewhere. Okay. So why is XPQ cyclic? XPQ are cyclic. I told you there's a spiral sim, right? That sends XAR to XPQ. So XRA is equal to XQP. Wait, is that it? No, spiral sim is supposed to work that way. What? Oh, it's because PA are collinear, right? Okay. So XRA equals XRP equals XQP. Okay, so we get that cyclic quad just out of the spiral sim. Like XPQR is always cyclic. And then YQPS is also cyclic. So if that's the case, then by power of a point, the other intersection here we'll call it X prime. Okay, so we'll rename this to x prime. And we'll name this other intersection point y prime. Okay, so the spiral sim will tell you that txx prime and ty prime, yeah, like they should be homothetic things because of power of a point. I think. Is that true? Yeah, by power of a point. So if p, q, y prime, then y prime should pass through t. This is unconditionally true. It follows by some homotopy argument. So where does that bring O into the picture? Can I get anything about point O? Maybe I try to do a phantom point argument. So if I have all this information, let's take the case where can I show in this picture that OR equals OS? What can I do a phantom? Thank you, Marianne Patino 23 for the follow. Why are PRQX cyclic? Oh no, the PRQX cyclic follows from the angle chase. No, we actually do have PRQX cyclic. From this unconditional spiral sim, we get the cyclic quad by another angle chase. Yeah, we should know PRQX cyclic by now. The reason is that angle XRP yeah, that angle is equal to that angle. Yeah, that cyclic quad is actually unconditional. I don't know what I'm supposed to do with O. Like, this angle bisector is not moving, and then eventually O is on the green line, and when that happens, I want to show like everything lines up, and I can't get it. Frick. I get something from that cyclic quad? I don't see it. What am I not seeing? Is A y prime S sim spiral sim to A O Y? Oh, that would be so nice if it was true. Oh man, it doesn't look like it's true. Is it true in the desired state? Well, I guess sort of in the desired state, like everything is true. Actually maybe not. Those numbers don't look the same. Do we need diagonals PY and QX? That seems advisable. I'm gonna draw this. Ah, frick. I don't get it. Like, how do I do with that random point? Oh. I concur with Omega too. I doubt it. Hi, Mark. I'm getting wrecked. Yeah, I just don't see what I'm supposed to do with this. Does x prime y prime pass through a fixed point? Maybe. I don't think it does. Should I just invert from T or something? That doesn't do anything good with O though. Like the whole problem is I don't know how I'm supposed to handle the circumcenter. Like I can kind of have a sense that the angle, the fact it's the angle bisector of RAS matters, but I don't really understand the circumcenter part like at all. This is very sad. ABM collinear? Yeah. No, ABM collinear is definitely true by radical axis. Like the radical axis always bisects the common tangent. I just don't see that why that does anything. Length batch and find AO based on C, PQ, and compare it to the length of the bisector of AXY. I don't think that's tractable. I don't think that's tractable. If we're gonna invert, it's through T. Because T swaps P and Q, A, XX prime, Y, and Y prime. But I just nothing I've seen convinces me that this O, like we know what to do with O. It's so late, yeah. We've been stuck on this for a while. Yeah, I construct points G and H such that X, P, G, and you want to construct harmonic conjugates? Then is GH parallel to PQ? What the heck? Where did that come from? I think I need to sleep. I mean, it might be true. I just don't know where you got that from. Like, I don't see anything that feels obviously projective. Like, everything so far feels spirally. Like, especially we have an explicit spiral sim XAQ to XPQ to XAR, and it, you know, does spiral thingies. In fact, I want to draw XAR again, and I'm running eyes. Things try. So this is the property that I think RQ should be tangent to this as well. I don't know if that does anything. Are PX and QR tangent? To XAR? Not PS, but not PX. Or wait, so QR is actually tangent. That follows by the spiral similarity we computed. Yeah, like that one is actually tangent. But I don't. Like I don't see what it does. Like I just don't have any control over this freaking point O. What am I supposed to do at this point? Are you sure OXPA is not a parallelogram? It can't be by symmetry, right? Like if it's a parallelogram, then also Q by symmetry AQYO is also a parallelogram, which is like not happening. Unless it's like some config issue thing where like one of them is a parallelogram, the other is a trapezoid. Which I guess is possible. Alright, how do I check that? I picked a different picture, right? Yeah, there. That's not parallel. Py prime abqy concurrent. Yes, by radical axis. So you're saying I should draw the there? Okay. Like, I mean, yes, but what does that do? Like, I can also draw, like, for example, the intersection of line px and qx prime. And well, that's what it looks like. It's this giant line. We intersected some radical xi, fine. Oh, I don't know what you do with that. Well, it's... well, that's a disappointing way to end off. If you prove... Yes, if we prove the x through y homotopy, we are done. We've had that since the very start. Inverted A. Honestly, that might work. I might believe inversion at A. So ARS is still like isosceles. What happens if I invert it? So I have this all this spiral junk. Can I? How much of it can I preserve when I invert? Yeah, I could invert. Did you? Yeah, the spiral is all proven. Yeah, the spiral stuff on that's written up there is all proven stuff. So you have a spiral simulator that makes xpq to xar, and one that maps y the symmetric thing ypq to yps. It gives you points x prime y prime q on those circles. It gives you the green circles. The only thing we don't know what to do is like what the hell is the point O? Like I just I know there's something I'm not seeing. After the... Does O go to the same point in both of them? You seem bored. I just don't feel like I'm getting anywhere. It's enough to prove that AP over AQ equals TP over TQ squared? Wait, what? Why is that sufficient? The heck? O go to the same point in both of them. So if I take XAR to XPQ through O, it lands on some point through there. How do I determine that point? Yeah, XAP... Wait, what? XAP is similar, XPQ. Yes, I assume you meant XAR. But yeah, we have that spiral sim. Thank you, Laceras. Laser US. With follow. How do I figure out where O goes under the homology? AOR is supposed to map to PQ and that wherever that point is. Thank you. Entry for flow. Because AR is equal to PQ. AR is equal to PQ? No, it's not. What? This looks fun. Yeah, but I'm really getting destroyed here. Do you need to know more than analytic geometry to solve this? What does more than mean? I'm not planning to use any analytic geometry, but the spiral we're using spiral similarity. I never drew that circle XAR. Don't know much more than algebraic geometry. Well, welcome to the stream. When O's on X, Y are the two original circles orthogonal. I don't... Which two original ones? If you mean this O1 and O2, I mean, no, because they weren't orthogonal to begin with, and, like, X and Y don't move those circles. How hard is the Putnam compared to the IMO? Depends on who you ask. The flavor of problems is definitely different. I personally think the IMO is harder. Or has more depth, I would say. Are we not inverting? I don't really want to, honestly. I would tolerate inversion at A. Inversion at T also seems like it might be promising. Uh, but I just feel like that there's something here. Like, we have spiral sims that we haven't really used. We have this R. Like, in so much as we don't know anything about O, we also really haven't used R, like, just at all. And I'm like very frustrated by this. I feel like I should be able to do something with this point R, but I don't see it at all. O prime be the image of O under either spiral similarity. Okay, which O? Then XAO spiral sims to XPO prime. Draw PR. What is PR gonna do? Wait, PR is already drawn. Okay, so XA, this is the angle bisector of the blue things. We don't know AX and AY are orthogonal in the red thing. That's what we want to show. Left for a while. You didn't miss much. This problem has been really... this problem's not going well at all. I really didn't want to invert. I might... Cause I know I'm supposed to use that spiral sim, and I can't get it. So there's a spiral similarity. The spiral similarity at X maps the blue point to the orange line, and then maps the orange line to the blue line. Where does it take things? Like, it's the composition of two spiral sims is a spiral sim. T and A need to be on the same Apollonia circle. Yeah. XY. Okay, so I need to. I want to compose two spiral sims. I think that might do something. So XAR, there's a spiral similarity at X, and it maps R to Q, and the spiral similarity at Y maps it to A. Right? There's too much junk in this diagram. Holy crap, I can't see a thing. Cleanup time. I'm actually gonna hide the green circles, even though I think they're really good. Yeah, so Y, yeah, there's a spiral sim that maps R, maps to. But we didn't use, like, we said there's a spiral sim and then didn't do anything, right? Like, that doesn't mean we've used the point up. So the spiral sim, like, where does this, if I compose the two spiral sims, it sends R to A, and, it sends A to S. Maybe? Okay, wait, actually, where does A go under the spiral sim at X? At Y? No, at X. Okay, so R maps to I guess R Q A. Meanwhile, S maps through X to nowhere. Okay, well, shoot. A maps to P. Where does that map through Y? To S. So, okay, so if O is on XY, then something's gonna happen. Okay, alright, okay. Cool story. Well, so I guess when composing spiral sims, it takes, the first one takes, so through X, the point R goes to Q, goes to A. And through, if I do it again, A through X goes to P, which should go to S. Is that right? It's so much harder to see the Y spiral sim because I've been staring at X the whole time. Okay, so fine. This is called rotation because AR equals to AS. So a spiral sim is determined by 2 points, right? This is a spiral sim that takes segment RA to segment AS. Yeah, that's rotation through O. So the composed guy is centered through O. Now, what about, where does X go? If I do... like the center of the spiral similarity, well, what's going on here? So X maps through, it's fixed under the first one, and then through the Y it goes somewhere. I don't know what that means actually. So if the composition of two homotheties has its center, what does that tell you about them? Or better yet, why don't I feed O to the homotopy? Like, I expect it to land back at O, so that will tell me some non-trivial information. It tells me that, so where's the question mark point? Oh, we're getting somewhere now. Oh, jeez, I was about to give up. That's how you use O. It's the center of spiral similarity because it's a rotation. So O goes to. How do you compute the center? I don't know. It's the O prime you described earlier. Okay, let's actually draw a point in. That seems like it'll be a useful point then. How do I construct it? Can you just do complex? Good idea. So the O prime is the image through a spiral sim centered at. Okay, let's check that worked. Okay, so there's a magic point O. We'll draw it there. And it lies on things. So you are composing two rotations and getting a rotation. Well, the spiral sims are not just like the XPQ to XAR is not a rotation. There is a scale factor, but it's canceled out by the scale factor going the other way. So what does that tell me? Okay. Oh lord, it's still this problem. Yeah, sorry. I spent the last like, oh my, how freaking long have I spent on this freaking? I'm so annoyed. Based on the chat logs. 10:30. Yeah, it's been about 2 hours. But like a lot of that was me just staring at. Shouldn't the Shouldn't have two rotations be a reflection? Wait, what? No, that's not true. Yeah, I'm annoyed. I spent so much time just staring at the picture and not being sure what to do. What program is this? This is GeoGebra. But I was supposed to compose the spiral sims. Am I sure I constructed O prime correctly? I think. Invert? No, I'm not inverting. I just got the spiral sim. Ah, I'm so aggravated right now. Oh my god. Okay, so the y xap goes to x o prime, right? Oh. No, what? Okay, what are we constructing? Someone please explain. Wait, okay. Shout out to VEnhance from AOPS user 305. I should be almost done. Is there any reason you never did this problem? I just never got around to it. I wasn't good enough to do it when I saw it on the actual test, and then the condition looked really strange, so I never really wanted to work on it after that. Thank you. Energy is always conserved for the follow. So XPQ goes to XAR, XQP. Let me just write out what the so XQP XPQ through X goes to XAR, and sorry, PQ through X goes to AR, but also through Y. Through the inverse map through Y goes to SA. No, I have it backwards. Let me write it consistent. Segment AR maps to segment SQ. Okay, I'm just confusing myself at this point because I'm tired. So XARO should map to XPQO prime. Okay, I see. I drew the O prime in the wrong place. Yeah, this is the... I flipped this. Well, would you look at that? What point is that? Are you going to game today, or is the live soft talk taking too long? It's because of this fucking spiral sim problem. I'm so fucking pissed. Ugh. Like, literally, this 1 hour. Yeah, I'll play some games after this because I need you to de-stress. I'm so annoyed. I don't think I need X-Prime and Y-Prime anymore. No, we're almost done. We have the... I feel like we're almost done because I got the spiral sim composition. That's the part that I was missing. Like, the part that I was missing was I was supposed to compose the spiral sims, which... Whenever this happens, it never feels natural to me. Like, it doesn't feel like I put two synthetic things together or something. Like, it's more abstract or in some way. And yeah, so I'm not surprised that nothing we tried before worked. Yeah. I should have tried it earlier, honestly. I just didn't think to, because I don't use it very much. O prime is fixed since AOR equals POQ O prime Q. Angle AOR. Yeah, you're correct. It is fixed. So triangle AOR has a fixed shape. So yeah, it's whatever. There's a fixed O prime here. Now, if it lies on line XY, what does it mean for O to lie on XY? Like if I compose two spiral sims, yeah, so O is a nice fixed point, and it... So XOO prime through the spiral sim is similar to what? AOR is fixed. O prime PQ maps to OSA. Hang on, what? Yeah, so XOA. Fine. So angle XOA by spiral sim is XO prime P, which apparently is equal to YOA, which is... I think the angle dump is the right to go. So apparently XO prime P equals YO prime Q. So like xo prime y is equal to po prime q. Xo prime y is equal to po prime q. O prime pq ar poq fixed, so that doesn't say something. No, it has to say something, right? Because it's not always true that xoa plus yoa is 180. Like xo prime p. The tangent at A to the circumcircle of ARS really looks like it goes through T. That's definitely false. The tangent at A is the perpendicular line through A and line AO. Or maybe, no. Yeah, that's the tangent. XO prime Y, PO prime Q. So, okay, XO prime Y. I feel like I'm still missing something I'm not understanding, because it's like the spiral sim lies on the line joining the center of the composition lies there. Like that says something, but I don't know what it says. Like if I have I need to think this through. I don't do this kind of thing enough. Like if I have to cut the knot rotation transform. But they're not they're spiral sims, right? They're not just plain rotations. Like the scale factors, I don't think they commute with rotating. No, the dilations like a spiral sim is the same as a rotation followed by a dilation at the same center. But the dilations don't cancel because like it's rotate dilate because you're putting two of them together, and the rotate through A, rotate through B, dilate through B, like the like if I dilate through some factor at A and then some other factor at a different point B, that is not they don't cancel. How long have you spent? It's been like 2 hours. I'm very angry. Yeah, so XO prime Y should be I believe that, yeah. XO prime Y. I agree that rotation and dilation through a common center commute. However, the centers are X and Y respectively when I compose the two things. And X does not equal Y. Actually, is XO prime Y always similar to... No, it's not. So when this happens, these two guys are similar. Okay. What do you need on JMO to make mop? It depends on the JMO. Wait, does that pass through B? That's really convenient if that's true. I don't know if that's relevant. Huh, okay, I learned something new today. Yeah, so O prime is the point such that, like, on that circle where I did that reflection. And, like, I don't know, something happened. Whatever. B is useful. I don't think it's useful. It just happened to show up when I drew it. O is the center of this rotation, sending AR to SA. That rotation goes through PQ. This should be almost there. It really should be almost there. I would really like to have an angle bisection. I don't know if that's gonna happen, but that would certainly make life easier. Yeah, I would believe rotate, transform, rotate. So XO goes to XO prime. Maps back down here. It's like rotated through this angle. I don't know. Like, okay, pretend they're equal. You got your angle bisection. Okay, so XO over XO prime is XA over XP. Okay. Goes YK over YA. You can tell I'm tired. Okay, so XA over XP. It should finish once I have the angle bisection. So equals OY over O prime Y. Oh, wait, why does that do an angle bisect? So I agree that it tells you that, like, this over this is this over that. Wait, I don't see why this gives... Which angle bisection are you claiming? Oh, O prime O bisects. Yeah, that's true. That wasn't the angle one I had in mind, but... On the other hand, the spiral sim should give me some random angles are equal. Okay, so... So O prime O... Wait, does it map anywhere? Does that have something to do with Apollonians? It looks like it. Like, so, I know that AO is supposed to bisect XAY. Like, I'm pretty sure that's equivalent. Also, another condition that would solve the problem. XO prime over YO prime. Actually, XO prime over YO prime. The XO over YO. Wait. Hang on, I'm confused now. Sorry, it doesn't bisect it. What am I talking about? I thought it did somehow. Ah. Thank you, right for the justice for the follow. Should be almost there. Where am I? Yeah, I can see O prime. There's a definitely Apollonian there. I don't think that solves the problem outright. XPA is XO prime O. Oh, what? Yeah, that is true. Yeah, that is what we wanted, right? I got so sidetracked by this point O that I didn't. Okay, so what happens is the collinearity makes the angle bisector theorem apply, and how on the other hand angle XP it's therefore the angle bisector theorem. Okay. So I don't even need this. I can just. Okay, we did it. The frustrating thing is, like, I know we were close the whole time. Well, not close. Sorry, close is the wrong word. I knew that there wouldn't be a lot to do. Like, I knew that I was going to use the spiral sim somehow, and it wasn't going to be like very involved. But man, I just could not work it out. Jesus. Yeah, so R and S are, yeah. The spiral sim was like just. What a sad problem. So what did I use the whole time? Just the spiral sim? Is it literally like the spiral sims compose and then I want to see just how little stuff that I used. I didn't even use the point T. I thought for sure that T was going to be involved, but it turns out to be superfluous. The tangencies are not really involved either, I think. Yeah, I didn't use this point. Didn't use this center. I never used that center either. I didn't even use the fact that O prime was a particular point. It's just some point somewhere. I didn't use this midpoint. I didn't use the point B. I didn't use this circle. I didn't use this. I didn't use this line. I didn't use T. So this is what we used. The argument is that by condition, XAR is spirally similar to XPQ. That's unconditionally true. Also, the other one is spirally similar unconditionally. So we can compose them because it sends RA to AS, so it's centered to O. And we can let O prime be the image. Then, if O lies on here, then first of all, angle bisector theorem applies because we use the same constant C here to say that this, yeah, because these are the same constant. Hang on. XO over XO prime, XA over, yeah, they are C. Because the same constant was used here, the angle bisector theorem then applies. And then it gives you the angles and you copy the angles. That's the complete solution. Yeah, we actually, I think T really hurt us. That point, T, it really burned. I didn't use this triangle for that matter either, or this line. I don't really care about the line. I care about segment PQ. So now I know why this is number 2. It's like, oh my god, we got baited. We got baited. Yeah, once it's done, it's like, oh my god. The only thing that happened was you translate the angle into spiral sim, the angle bisector theorem applies, uses the last length condition, and then that's it. It's just a spiral sim problem. That's it. There's no geometry. Almost no geometry. You have to like notice that like this angle is equal to this angle. What a stroll. It's all because of that point T. It's all T's fault. I blame point T.